of 10.3. And these are actually problems like we started with last class. So we want to multiply and simplify the end of 10.3. So what does the first direction tell you should do in one word? Multiply. I cannot stress, read these directions, or you're going to make the problems a lot harder than they have to be. So don't try to simplify, multiply, simplify. Just follow those two easy steps. First step says you want to multiply. How do I multiply two square roots together? Yeah, I just multiply their radicands. So I just take the 8 times 10 under a square root. So I've got a square root of 80. We put our... If you have that 10.1, you might want to get it out. You should have left more room to the left. So step 1 says multiply. Step 2 says simplify. So I want to know, do any of my perfect squares evenly divide into 80? If more than one does, I want the biggest. So do any of my perfect squares divide into 80? 16. Okay, 16 times what gives me 80? 16 times 5. So this goes back to what we did last class. This is what your drill would have been on today. The simplify part says look for any of these perfect squares that evenly divide into 80. So there's actually 2 of them. Both 4 and 16 work. You always want the larger. If you're using a calculator, let's see, 80 would be right here between 64 and 81. So take your calculator and do 80 divided by 64, hit equals. It's not even. 80 divided by 49, hit equals. It's not even. 80 divided by, and work your way down until you find one that works. But you should only be trying those numbers or you're wasting your time hoping to get a perfect square. So the square root of 80 I can break up as the square root of 16 times 5. And then what part of that comes outside? What's the square root of 16? Square root of 16. 4. So 4 out front, square root of 5 left over. Sarah? Yes, do that first. Just follow the order of the directions. Because if you try to simplify, like you could simplify the 8 first, but then you're going to have to multiply part of it with the 10, but then you're going to have to simplify it again. So it just creates a lot of extra work. If you multiply it once, simplify it once. It's the shortest way to do this problem. And that's, like I said, just read the directions, 1, 2. Multiply, then simplify. So B, I want to multiply, then simplify. So the multiply is the easy part. Do that first. Don't try to simplify first. Start with multiply. So I can multiply together my 2 radicands, and you don't necessarily need to write this step here. But when you have 2 square roots, you multiply them under a square root. That's our product rule. So I'm looking at the square root, let's see, 175 times 2 is 150. How about x to the 3rd times x to the 5th? X to what power? 8th, yep, add those together. Y times y squared gives me y to the 3rd. And then I have z left over. So that's step 1, multiply. Step 2 is simplify. This is what we did last class. So I actually want you to try to simplify this one. Try to break up your numbers, try to break up your variables. If you weren't here, you might ask your neighbor. But try to simplify that one. So how did you split up your number? 25 and 6. I think that part, for the most part, looked good on everybody's paper. It's 25 and 6. Variables were giving us a little bit of a kick. So what is the key word for simplifying variables? Begins with a D. Division. Whenever you see variables in these problems, it's always based on division. So can I already divide 8 by my index? Yes. So I'm going to bring it down. Now the reason I don't just divide it at this step is I've still got everything under a square root. So I don't want to divide it because then it would, if you divide it, just make sure you bring it out front. But I like to do one big line and then one simplify. How about the y to the third? Can I divide my 3 by my index? No. So how did people split that up? y2, y1. Now notice, and I think this is part of the confusion, I'm leaving everything under a square root now. I'm just working on splitting things up if I need to. And then I'll simplify it in one line, just so you don't simplify some things now, simplify some things later. Did I divide? Did I divide it too many times? One line of either carry down or split it up, and then one line of simplify, I think is the easiest. And then the z. So now that I did one line of splitting it up, how do I, or I should say, which of those factors can I simplify? 25 comes out as 5. X to the 8th. When it comes out front, it's x to the 4th. You divide your exponent by your index. Then I take that y squared. I divide the exponent by the index. So I just have y to the 1st outside. And then left over a square root of 6yz. I never even got to do anything with the z. How did I know the z was already simplified? The exponent's less than the index. So that means the whole thing is just going to carry through. I can't take it out. It's already simplified. Questions? So with the x's, the exponent could already be divided by the index. So I don't need to split it up. The whole thing's going to simplify to out front. The only time you're going to have something left over is if you can't divide the exponent by the index in the beginning. If you can divide it, you know the whole thing's out. Any other questions? All right, and we're actually going to skip the last example. This is one of our time savers. We may see this again later. I will post the completed notes onto Blackboard. So if you want to try them, you can check your answer. I will post the completed notes onto Blackboard. But for now, let's look at some of 10.4. So we know you can multiply radicals. You can multiply any radicands together and then simplify. Adding is much more particular. Just like adding fractions. What do you need to add fractions? Same denominator. If you want to add variables, your terms have to have the same variables. So, for example, what's 2x plus 5x? 7x. Think about how we got that. How do you get 7x? What part do you add? What part are we adding? The coefficients. You just took 2 plus 5 and you kept the x on the end because that's what made them common. Like a common denominator, you carry it through a problem. You don't add denominators together on fractions. When I'm adding variable terms, I don't bump up the variables. I just add the numbers out front. Oops, got away from me. The same thing's true with square roots. You never actually add the square roots. You never add square roots. They act like an x and that they carry through. But the only time I can combine radicals is if they have the same square root, the same cube root, the same fourth root. So on this first example here, notice how they both have a square root of 15. That's what makes them like. If their square roots don't match, you cannot add or subtract. They have to be like terms, just like you have to have x's. You can't add an x and a y term. You have to have both x's. You have to have both square roots the same. The only part you actually add are the numbers out front, the coefficients. So you add the numbers out front, you keep whatever made them like on the end. So 5 square root of 15 plus 2 square roots of 15 is just 7 square roots of 15. So if I look at C, are those two like? Yes. What makes them like? They both have a cube root of 2y. So what parts do I add? The 9x minus 15. That's the only part I combine. And then whatever made them like just stays on the end, just like an x would. So if I take 9x and I subtract 15x, negative 6x, and then I'm still just hanging on to that cube root of 2y. So in D, which of those do you think are like? The 6, the term that starts with a 6, the one that starts with a 5, with the square roots of 10. So if they have a square root of 10, we know these two are alike. The only part that we actually combine are the numbers out front. So it's the 6 plus 5, and then we keep on the end 1, just 1, square root of 10. You never add radicands. Never add radicands, you just carry them. So I'm looking at 11 times the square root of 10. Are my other two terms like? Yes. They both have a cube root of 10. So the only part I'm going to combine are their coefficients. What's the coefficient on this last term here? What number is out front of this last term here? Negative 1. And then I keep whatever made them like. So negative 3 minus 1 is my negative 4. And then I just keep that cube root of 10. And those don't go together because the square root of 10 is not the same as the cube root of 10. So you may end up with more than one term in your answer. E, are those like terms? No. So right now, these aren't like terms. I can't add them together. The square roots aren't the same. So they're not like terms. I can't add them together right now. But is there anything maybe I could do to the square root of 50? Devin? Yeah, break that into its factors. So these aren't like terms yet. What we need to do is simplify them first, individually, and see if once we get them in their simplest form, maybe they're like terms. Maybe they're not. So the square root of 50, let's go back to what we started with, that simplify. I'm going to try to break it up, see if any of my perfect squares evenly divide into 50. 25 and 2. So it's the square root of 25 times 2. So what number's out front of the radical now? 5. And what number's underneath? So it's 5 square root of 2. Now for the next one, what's the big 5? What's going to happen with the big 5? You're going to multiply it. So don't forget to bring it down, but all that means is 5 times whatever else happens in that term. Big numbers are multiplied. Coefficients are multiplied. How about breaking up the 18? 9 and 2. So I have the square root of 9 times the square root of 2. So what number's coming out front with that 5? 3. So 5 times 3 times the square root of 2 gives me that second term to be 15 square root of 2. Are they like terms? Yes, these two are like. And what makes them like? They both have a square root of 2. They're only like if the radicals match. But which part of the problem do I actually add together? The 5 and the 15. So 5 square root of 2 plus 15 square root of 2 is 20 square root of 2. When you're adding or subtracting, you should never change what type of square root you're saying. It's the same type of square root, or you could not add them together. I'm actually going to ditch F. Again, I'll post it on Blackboard, but I'd rather do G. So I'll post the solution to F on Blackboard, but let's look at G. So as they sit, are those problems like? No, their square roots don't match. It means we can't add them. But we can try to simplify them first. So big 3 out front is just 3 times. Now we got to look at that square root of 54x. Looking for any of my perfect squares that might evenly divide into 54. 9. So we're going to do 9 times 6. What about the x? It's just going to stay there. If there's not enough x's to take them out front, we've only got 1. We needed a minimum of 2. So x is just going to carry through in this square root. So what's coming out front? 3 times what number? 3. So 3 times 3 times the square root of 6x. So that first term is 9 times the square root of 6x. And then I have 2 times the square root of 150x. So let's break up that 150, which I think we already did. But what's my pair for 150? 25 and 6. And again, I don't even have enough x's to possibly take any out. There's only 1, and a square root, I need a minimum of 2 to simplify a variable. So the only thing I'm going to get out front is an extra 5 for the square root of 25. So I end up with 2 times 5, which is 10 square root of 6x. Can I add these two together? Yes. Now they are like, because they both have a square root of 6x. So if I have 9 square root of 6x plus 10 square root of 6x, how many square roots of 6x do I have? 19. You only ever add the coefficients. But before you can add, you might need to simplify. If they're not like to start, try simplifying, then see if they're alike. Questions? Sarah? Then they can't be combined.
What would you write?
Can't be simplified, or just copy the problem over. If you copy the problem over, that's as simplified as it gets. Well, actually, we will run into that in the multiply problems. And once you get down to that line where nothing can be combined, that's just your answer. That's what you'd write as your answer. That is the time that we will see it. Any other questions? Now we're going to talk about our quotient rule, which we've actually already worked with our quotient rule, one of the ways. So we saw this in 10.1. We saw the one big square root that was a fraction, and we broke it into 2, and then simplified them individually. So it's the same exact thing here, except not everything's going to be perfect necessarily. So if I look at the first problem, it says simplify using the quotient rule. And I have one big square root. And I'm asked to simplify. So if I'm asked to simplify and one big square root, I'm going to break that into two. One for the numerator, one for the denominator. And then I'm going to look at it, and now we might not be able to simplify the whole thing, which we could in 10.1. Can I simplify the square root of y? No. I've only got one y. At a minimum, I need 2 for a square root if I'm going to simplify. So that means the numerator is going to stay the square root of y. And then what's the square root of 36? 6. So I can simplify the denominator. So my answer is the square root of y over 6. B, you would start the same way. You're going to break that fifth root up. We don't see fifth roots a whole lot. There's probably one on your homework, which is why this one's on here. The smallest fifth root, the smallest perfect fifth, is actually 32, which means the fifth root of 7 can't be simplified, because 2 to the 5th power is 32. That's your smallest if you were looking at a list of perfect fifths. So the numerator, again, can't be simplified. However, the denominator, and you can put that in your calculator. I'll tell you, in this section, the denominators do actually all work out to be perfect. The fifth root of 32 is 2, because 2 to the 5th power is 32. Now variables, we should be able to do variables for any index. What's the key word for variables? Division. So just take the 15 and divide it by your index. And that means x to the 3rd is out. So when you see simplify, now the reason I'm saying the directions here are important is there are other problems that look like this to start that have a different process. So we're trying to connect the directions with the type of problem. So it says simplify. You've got the one big radical, break it into 2. And then simplify them individually. Because again, there are other problems that look like this, but with different directions that are asking for something different. Let's start with the denominator. That's actually the easier one here. The cube root of 27y to the 12th. What's the cube root of 27? 3. It's a perfect. You don't have to break up everything. If it's on the list, and now you can either put it in your calculator, you can look on your card, you can get where it came from. So the cube root of 27 is 3. How about the cube root of y to the 12th? y4. So you just take the 12 and divide it by 3, which tells me I'm down to y4. Now how about the numerator? Is the numerator perfect? No. So the numerator is not perfect. So if I look at, I'm just going to move mine down. All right, let's start with the 8. If I'm going to make one line under a cube root and then one line of simplify, do I need to split up the 8? Can I bring it down? If you're going to split it, how are you going to split it? You're overthinking it. Look at my list of perfect cubes. Is 8 on there? Yeah, so just bring it down. You don't have to split up everything. First check is always, is it on your list? If it's on your list, don't break it up. And then how about the x to the 4th? And you're going to do x and x. What am I trying to do with my variables? What's the key word? Division. So I can't divide 4 by 3. What's the closest number to 4 without going over that I can divide by 3? 3. So I'm going 3, and how many x's do I need left over? 1. So what's coming out front is 2x. What's left over is the cube root of x to the first. So I can, right here, I can take that 3 divided by 3, 8's on my list. What's your question, Shakira? Ask it. Questions? Sarah. So what's the cube root of 8? It's 2. So like if you put the cube root of 8 in your calculator, it gives you back the answer 2. If you're looking at that chart from the front of 10.1, if you go to the cube root of 8 and trace it back, it comes from a 2. And then for the x to the third, we take the 3 and divide it by 3. So the 2 comes from either your calculator or from that list from the start of 10.1. For the variable, divide your exponent by your index. That's everything that's out front. What we didn't do anything with is the x to the first. That stays underneath. Any other questions? All right, so the one last thing is dividing. Works just like multiplying. Divide your radicands, simplify your answer. So if I have A, and again, look at the directions. The directions say to divide. You can divide, you can multiply radicands. You cannot add or subtract them. But you can multiply, you can divide. So if I see the directions divide, I'm just going to take my radicands and divide them. So square root of 54 divided by the square root of 2, divide my radicands. Square root of 27. And then the second step is, if possible, just like with fractions, you always simplify your final answer. So the square root of 27. Do any of my perfect squares evenly divide into 27? 9. So that's the divide step. The simplify step is what we've been doing, where you then split it up. So I'm going to end up with a 3 square root of 3. So divide, just divide the radicands and then simplify the answer. So for B, when you see the two separate square roots, you certainly can combine them back together. And, oops, that's a Y. And divide the radicands. When you divide variables, what do you do with those exponents? Subtract them. So I'm going to have the cube root of x to the 6th, y to the 5th. And now we want to simplify it. So I'm going to do one line where I either bring things down or split things up, and then one line where I simplify them. So in terms of variables, x to the 6th, am I good with that right now, or do I need to break it up? I'm good with that, because I can divide 6 by 3. So I'm just going to bring down x to the 6th. How about y to the 5th? Am I good with that, or do I need to break that one up? I got to break that one up. I can't divide 5 evenly by 3. So what's the closest number without going over to 5 that I can evenly divide by 3? 3. So I'm going to take a y to the 3rd. And how many y's are left over? 2. Y squared. And now let's see what comes out front. So I've got my 2 that evenly divide. So I take 6, I divide it by 3. I take 3, I divide it by 3. So I get x squared y and then the cube root of y squared left over. Bless you. Questions?